Good morning. Uh-oh, YouTube said stream is bad. Uh-oh. How are we looking, folks? Good morning, everyone. Whoa, the chat's going. I haven't even read back on the previous chat. Coffee. Stream is fine? Okay. Awesome. Because this says stream status bad. We're not receiving video data fast enough. I brought my own popcorn. Someone mentioned popcorn. Although I'm not really going to eat it on the stream. Yo, Julian, what's up? So who's here? Let me just go back. Gotta say hi to everyone. Whoops. Whoops. Someone can't click the thing. Gregor's here. Robson. Azzy. Michael Best. Hello. G'day, Alan. Oh, Unexpected Maker's here. Leo's here. David's here. Maxine R&D. Hello, Colin. Des is here. Dylan Buckley. Hello, Dylan Buckley. Dylan Buckley is new, I think. If you are, welcome. Michael Swan. Hello. Feed look fine. Cool. Just Dave is here. Hello. Hello, Josh. Wolfgang. Andy. Hello, Colin. And Paul the Curtains. Hello, all. Okay, that's just a, someone mentioned popcorn earlier. So I took out some Cool Pack popcorn. My son eats this stuff like it's... anyway. Wow. Okay, put that away. How's everyone doing? Hello, Akmalda Research Centre. G'day, Peter. Dylan's been watching, but quietly. He's been lurking. Hello, I'm glad you said hello and stopped lurking in the background. That's awesome. The weather here in Melbourne is picking up. It is awesome looking. Yes, I got new cutting mats. As you might have seen in my Random Bites video for September. All different colours, but blue is my favourite. So, hello Mike Herbst. And Sebastian. And Rob. Hello, Rob. Rob's been hunting around the house to find phone. Are you watching on your phone? Probably want to watch on a bigger screen. You might miss any detail today, I think. So Rob got a... Rob, can I tell everyone? I'll wait to see if Rob says I can tell everyone first. Now that there's no delay. Hello, Gary. Nothing wrong with... No, there's nothing wrong with lurking. There absolutely isn't. Not everyone is as forward as other people in, communicating, saying hi, putting themselves out there. That's totally fine. Lurking is okay. Okay. Rob's been playing with a new toy, but I'm not allowed to say what it is until Rob says. Oh, right, okay. Oh, I can. Rob got a microscope. He got a microscope like mine, and guess what? He got all the parts for it. I'm still waiting on my eyepieces. I still can't use it. Yet, he got eyepieces and a manual in his microscope. Devastated. Hello, Chris. Good morning, all. Wow, so this is going to be a bit of a weird stream today. I'm just going to let everyone know, because it's just going to be kind of a review and me just doing some testing on the Rev2. So it'll give everyone a really good look at the good and the bad, because there's good and there's bad. They saw your videos and unexpectedly delayed parts. Hello, Gary. That's a new Gary. Welcome. Pretty sure I haven't seen Gary before. Then again, there's so many people in the chat these days that as in that's a different Gary. There's two Garys, two new Garys. Gary Evan and Gary Seaman. So, yeah. If I say hi and welcome as a new person and I've said hi to you before, I apologise. Yeah, so we're going to do some interesting reviewing. It's the timing. Yeah, it's tough to find a time, Gary, that works for everyone. When daylight savings switches, I'll be able to either start later or I'll be able to start the same time, and it'll be an hour earlier for everyone, or even 2 hours depending on when it is. So I'm looking forward to that. Because a lot of you start very late to watch. So we should get on with this. I'd like to get on with this. Ooh! Has he got a new microscope too? He got the Andon Star. Excellent. New microscopes for everyone! I still haven't used mine. I still can't use mine. I've tinkered with it, but it's been relegated to the back of the desk right now. Oh, it's amazing when you can actually see up close, see what you're doing. So, let's get started. Let's at least start having a look at some stuff. So here's TinyPICO 1. You might have remembered that in my TinyPICO 2 stream I did, the review stream of what I was going to do, it was really just a board rearrange and adding a matching network. But I changed my mind, as I do. More light. Really? More light, okay. Is that more light? Is that enough more light? I can't get any, is that close? That's as close as I can get. Okay. So that's TinyPICO 1. That's obviously got the JST connector on the back, so it's sitting on a bit of an angle. And this is, I'll do the same one on an angle, TinyPICO 2. Ready? Da, 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 da. So I ended up making TinyPICO 2 smaller. Center the mat to the shot. Oh, really? Okay, I'll give you the bullseye in the middle. I have to move the mat. There we go. Now the mat... Well, that's not actually the center, by the way. I just thought I'd say. It's the center horizontally, but not vertically. But that's fine. That's fine. Yay. Just for everyone's OCD. We're now in the center of the mat. How's that? Except my mat's gone off the edge of the desk now. Not quite. So that's TinyPICO 2. I'll do a flat version so you can see. So it is smaller. I made it one row. Now I'm trying to position it always on the target. So I made it one row, head a row smaller. And that was a challenge, because this is still a 2-layer board. This is packed in tight. Let me tell you, it was a fun board to build. I did it with my magnifying glass. It was doable, but it was a much harder build to do than TP1. But it's also a much better looking board. It's laid out much better. And, yeah. Thank you, yes. I was quite impressed with the reduction in size. It took me quite a while to get it right. But it's got its issues, and we'll talk about that. So this one has the matching network on it, as you can see in this bottom corner here. There's 3 little components here. Well, actually, that one doesn't have the components on it. I apologise. Try that again. We'll go. Let's get rid of TinyPICO 1. So you can see here there's matching network components on here. There's an inductor and 2 caps. Yeah, the size is cool. It's not going to get any smaller. I'm letting you know now. Bye, TP1. Say bye. Bye. You've been great. Actually, TP1's sticking around today because we're going to be doing a bit of a comparison between TP1 and TP2. I think you're a tiny rev away from something that could be offered from all the typical maker supplier sources. What are you saying? So I'm one rev away from perfecting this so everyone can clone it? Is that what you're saying, Peter? I hope not. Anyway, no, I think I'm more than 1 rev away, unfortunately. We'll get to that. So let's talk about the good. So this board not only was a relayout, it was a relayout for a reason. It's actually got a completely new power path. And I'll say thank you to Chris on the chat here, Christoph, for helping me with the power path, because it was quite a unique, well, it's not overly unique, it's unique to anything I've done before. Oh, you think so, Peter? I don't know. I don't know if I'll ever be able to do these at bulk, but we'll talk about that another time. So this has got a completely different power path. So one of the problems I did with, well, it wasn't a problem, it's the way every board is that I've ever seen that uses charge circuitry on there, is there's no way, or there was never an implementation to turn off any of the components when it was only on battery. So if I plug just the battery into this, and I run this is TinyPICO 1, this is just doing a, actually this is doing a Wi-Fi scan now. I changed the code on it, that's fine. Told you not to mention me, So, by the way, I'm doing the ultra low latency again today. I hope it's working okay. I was going to do the middle latency one, but I thought I'd try this one again and see how we go. So, excuse me, when this is running off battery, not only does the power light still come on, which doesn't draw that much, really, but none of the rest of the circuitry is technically turned off, right? There's still power going to the CP2104, there's still power going to both the charge and the regulator. Obviously, we still need the regulator. There's still power going through this circuit unnecessarily. So, a lot of buffering, so pause for 5 seconds. Okay. When I get my pick and place, okay, I'm gonna, yeah. No, okay. So I don't think a pick and place is gonna help with this. I've actually spoken to some people about it as well. The cheap pick and places, you know, a Light Pacer or any of the $3,000 ones you get from China won't build this board. The components are too close together. It's not going to be able to position the 0402 parts close to the other parts. Just the heads on them and the position on the heads aren't good enough. Like, so could this be pick and placed? Absolutely, but it needs a good pick and place machine, and I'm looking at probably $10,000 to $15,000. Hello, Tim. $10,000 to $15,000 for a pick and place machine that's going to be able to do that type of placement. If you see how close everything is. So I don't think that's on the cards for me right now. But anyway, we'll get back to this. Licensed one has their own pick and place. Okay, let's just stay focused on this for the moment before we talk about how I'm going to distribute. It's not finished yet. So one of the things I wanted to do when I was redesigning this was to put a different power path in to shut off power to anything that doesn't need power when the battery's running. So I'm just going to unplug this, and plug this in. Now this is, I believe, running a special blink code. Now as you can see, it just blinked, there was a little flash. There's no power light turned on. And I've shut everything down that I possibly can when it's running off battery to reduce overhead. Now the TinyPICO itself takes approximately 50 milliamps minimum. When all the antennas are turned off and it's not doing anything, it still draws 50 milliamps, which is pretty bad. Well, up to 50 milliamps. There are a few things you can tweak to reduce that. So on this particular version here, what I'm going to do is actually show you what I'm getting in terms of power on here. We can do a look on. Okay, now I'm going to have to do it on my multimeter, because my benchtop power supply doesn't, it's 3 digits, but it doesn't go into anything below milliamps. So what happens is well, you'll see in a moment. I need to swap this over, put it on milliamps, turn it on. I'm going to pull the battery out just for the moment, and I'm going to wire it into my power supply so I can go in line. Hi David, good morning. Yeah, the board's looking very good. Very happy with the way it's looking. But looks can be deceiving, which we'll get to. So I'll pull that just for a moment, just so you can see what I'm doing. Got my multimeter, I've got my benchtop power supply, I'm just putting my leads in here. It's set to 3.7 volts, and I'm just currently limiting it to 100 milliamps right now. I am connecting my positive to my... There, I'm going... that, and I'm going to put my positive on the battery, which is the first pin. And as you can see, whoop, if I turn it on, actually, okay, this is going to give it away. That's fine. I'm going to turn it on. So it takes 38 milliamps, and then what I do is I put it to sleep. So, okay, I should explain what the code's doing first. So what the code does is every 15 seconds, it wakes up, it blinks, it does a bunch of stuff, and then it goes back to sleep. So you can see it's woken up again. So when it's awake, I've managed to get it from 50 milliamps down to 38 milliamps. And when it's asleep, I've got it down to 160 microamps. So that's shutting everything off I can possibly shut off. Now the Pico is designed to run at 160 microamps when it's in deep sleep, but still using the coprocessor. You can get it a little bit lower apparently, you can get it down to like 5 microamps apparently, but I've not been able to do that with any of the code when it's just running off the RTC. So this is using a timer, a deep sleep timer, and every 15 seconds it wakes up, it blinks, it does some stuff, and then it goes back to sleep again straight away. So in my TinyPICO 1, when it went to sleep, it was at 7 milliamps still. Because the Pico was asleep, but the other components were still turned on. So I've managed to shave off 7 milliamps, just under 7, well, it was actually 8. It was 7.5, like it fluctuated a little bit. I managed to shave 7 milliamps off my power usage on battery, which is a massive amount of power. So I am super, super happy with the power path on this. Could it be tweaked a little bit more? I'm sure. So I'm using 2 different MOSFETs on here. I'm using an N channel and a P channel. A P channel to turn off anything that's the USB. CP2102 takes in sleep. I'm using the 2104, but I'm not sleeping it. I'm actually shutting it down. I'm shutting. Well, I'm shutting down. What I'm doing is I'm cutting off the VBus, which it's got the VBus sense on the chip. I don't know whether that puts it to sleep or whatever it does, but it goes right down. But it still could be, like, it's kind of hard to work out, because I can't put my multimeter in line with any of the components. I can't tell which component is taking which amount of power. So it could be the CP2104 taking 80. I don't know. But I'm pretty happy with this. I don't have another board here that has charge on it that has as good a power as this. My Lowland boards take 5 milliamps when they're sleeping. My Feather takes 8 milliamps when it's sleeping. So, as I said, I might be able to get this lower. I don't know how I could possibly get it lower. Thanks, Peter. But that's pretty impressive. So that was the first thing I sold. So the rearrange was also about, it was about making it smaller. Let me just get a bit closer again. Here we go. I'm going to turn off my power supply because it's noisy. Can everyone hear it rattling, the noise? So I still have to fix the fan. Let's focus this. So yeah, it was about rearranging the board and fixing the power path, which I did. Now I put the matching network on, and the results were, you ready? Drum roll. The results were terrible. So in terms of performance, where's my, I will show you the order of my performance. Wow, this is unrehearsed. Okay, my TinyPICO 1 is the best Wi-Fi reception I have out of any boards I have, and it matches and sometimes beats my MacBook Pro. hey Tabletronics. Then my MacBook Pro, which I don't have a picture for. So here we go, here's my MacBook Pro. Right? So it's 2016 MacBook Pro. Then this, so a Room 32, and then my TinyPICO Revision 2. Best, worst. And I thought that was a shocking result. So that was with the matching network on. And the matching network I've got right now is just the standard reference from the Pico kit that Espressif make. So it's their schematic and it's their values. And I knew it would be not necessarily a good match because obviously their board is wider than my TinyPICO 1 and it's about this long. Whoops, can't see my fingers. And it's about this long. So it's a much bigger board, very different placement of parts, bigger ground planes, all sorts of stuff. So I knew it wasn't going to be perfect, but it was, I mean, it still works, and I can still connect to Wi-Fi, and I can still pull data, and I can do all that type of stuff. But where this is jumping around between -55 and -65 in Wi-Fi strength, this goes down to -80. Sometimes -77, but often -80. So what did I do? Well, I started ripping the network apart, the matching network. And I spent about 2 or 3 hours, and I know it doesn't sound like a long time, but firstly remember I've got no equipment here to test anything with, right? So, hang on. I'm determined to drink my coffee while it's hot. So all my tests were me, with it plugged in, I wrote some, I did some special Wi-Fi scan code that did counters and stuff to let me compare, because every time you run the scan, you get a different result, right? And then the longer it runs scans for, it actually improves the results. But I'm holding it like this, and every time I move it, the scan changes. And every time it goes upside down, the scan changes. And every time I do this, the scan changes. And every time I move my head, the scan changes, right? Because these are really delicate. Anything with an antenna is delicate. But the smaller the antenna and the smaller the space, the more noise, the more influence on things around it, right? So all I have to do is move my hand 2 centimeters to the side and I'd get a different result with this Wi-Fi scan, which is super frustrating because it makes it very hard to know what changes you're making are having any effect. But what I did was I ripped off the network completely, all the parts, and then I started adding individual components a bit at a time. Is the signal polarized? Well, the signal does go 2 ways. It's not, what I mean by polarized, as in the component direction. The signal has to go 2 ways, obviously, because it needs to send and receive, so it can't block. If that's what you mean, Andy? Not quite sure what you mean. So I started switching components out. I started repositioning components. Now, 2 of these components are decoupling, and one of them is inline. There's an inductor that's, I don't know what an inductor does in a decoupled position, as in going to ground. I mean, it should just be holding charge, I believe, or I don't know if that only works when it's inline, as in like polarized light. Right, okay, I don't know, Andy and Azzy. I don't know at all about enough about RF. I'm way out of my realm here, way out of my depth. Yeah, I'll let someone else with more smarts answer that one, like Peter. Right, okay. So the inductor, so I've tried the inductor, so what I did is I tried each component individually, and then if I needed to, I just bridged them across with a tiny bit of wire wrap. I've tried rearranging each position of them. I've tried just doing one of them. I tried moving the inductor to inline. I tried all sorts of things. I also tried different values. So when I ordered these components, I found some other reference online of other antennas and people using other value caps. So when I ordered these ones, I ordered a bunch of other ones as well, and I tried all sorts of different combinations. And got mixed results, but what I found was anytime I have any decoupling caps on this network, so I'll put that back in the middle, anytime there's any decoupling on this network, the quality goes down. So the best version of this running is when there's no matching network at all and it's bridged. That is the best version, which is pretty much taking it almost back to what the TinyPICO 1 is. So anytime I introduce any components on this, the quality in my terrible tests goes down. I managed to get it as good as occasionally hitting negative 60s, but most of the time hitting like at negative 72 with nothing on here. But remember, even by removing everything and just soldering on a little bit of wire wrap, the bit of solder, the bit of wire wrap is also adding impedance to the network. So it's like I've got too much impedance on my network side to match the antenna. And anything I do on the network side is making it worse. SB rerun cal on every boot. Does it RF calibrate? I don't know. Electronics? I mean, obviously it boots up and it turns the antennas on. Although the test I was doing just before has the antennas turned off. So every boot it turns the antennas off. Central and away from the button. I wonder if that's having any effect on too. So there are a few things, right? So it could be space around the antenna, right? There's obviously less space on the Rev2. There's a little bit of less space on the width, and obviously there's a button here now as well. Although I don't know. I mean, I've seen other designs that have things even closer to their antennas than what I've got. Things like different size solder blob will affect RF voodoo for you. Yeah, that's right. Like, so every time I was resoldering things on, it was affecting stuff, right? I've got as little solder on here as I wish I could get. Let me see if I can focus this. Right, I've got as little, I mean it looks like a lot there, but I've got as little as I possibly can on there to bridge that over. But it's a huge amount, and it's affecting things. It's a good idea. Why don't I give you guys an even closer look if I can? Because it's pretty small. See if I can focus on that. There we go, even better. Okay. Sorry that it's not quite straight. I'll try to get it straight. Wow. So, yeah. So I'm way out of my depth here when it comes to trying to understand how to improve this, other than make more space. But obviously, more space means, you know, a bigger board, right? Going bigger again. But I've got a couple of things in the works. So the first one is I've reached out to a guy in Melbourne called Christopher, who has done a lot with RF stuff, and he's helped a few companies get their RF stuff through certification here in Australia. So he's been overseas. He's back this week. We're going to catch up, and he's obviously got access to spectrum analyzers and all sorts of stuff, and he knows how to use them. So we're going to have a look at what I've got and see how we can improve that. So that's great. I'm going to have someone with some knowledge help me out on it. You have too much capacitance in the LA pin to the ground, poor. So next, Rev, try a thicker trace from the caps to the antenna. I think you have built-in inductor of that final cap to antenna trace. Right, so just to let you know, my next revision is already in manufacture, so we'll talk about that shortly. So any suggested changes like that would have to happen in revision 3. Revision 4. Revision 3 is already being made. It's stuck in the 95% finished mark, but everything in China is closed right now. So interesting, all of the reference boards, so obviously I can I've got access to Gerbers and stuff for the Pico kit, anything that's open source or shared information. None of them have a thick trace to the antenna. I've been trying to, like, my implementations have been trying to be based on anything I can find as example implementation. They were closed 2 weeks. They were closed a couple of days last week, and then it's a week-long Chinese holiday, and they open again tomorrow. So, yeah, it's been a bit frustrating. I've got parts stuck at LCSC, and I've got boards stuck at JLC, but I won't use the word rushed, because I didn't rush it. I'd already been working on it for a while, but I rushed them into production to make sure that I'd get them as quick as possible after the holidays. I didn't want to wait till and submit them now, because the boards I've got made now are a longer build time, and I really want to move past revision 2. And I'll explain why. So, there's one other problem with this board, and this also had the same problem. I've made it worse here, and I need to work that out as well. And that is that these run hot. Hey David, yeah, the button is straight. For some reason, all my buttons, have a look, they shift when they're on there. You see that? It's also maybe not as much, but see it's rotated. I need to go to a 2-pad button instead of a 4-pad button. I don't know. I put them on straight and they shift inside. I think the pad size and the feet size are just wrong, and the surface tension just rotates it. I think that's what's happening actually. Yeah, it's really annoying. So these get hot. These boards get very hot. Now, when I say very hot, they're still under spec. UV glue. No, I don't think so. They're still under spec of, the temperature. The chip, according to the data sheet, can run up to 85 degrees. I've had them running at 60, 66. And obviously the killer is when it's using the antenna and Wi-Fi. Because it pulls anywhere from 150 milliamps to 500 milliamps. 90 degrees away from the board, i.e. get antenna as far away from the network as possible. So the antenna, the documentation on the antenna says you need to get the antenna into the bottom corner of the board, like it is now. So apparently this position here was wrong. In terms of getting it away from the network, every board I've seen has the network as close to the antenna as possible. Yeah, I can't pivot the red dot because then the red dot, then my board is that long. So that's not an option for me. I'd have to go for a different antenna as a test off the board. I mean, I guess I could try it. I don't know. I mean, it definitely makes a difference whichever way I rotate the board when I'm holding it as to the quality. But the fact is, this... I've just wrecked my focus. Sorry, folks. This works great. This works as good as or better than my MacBook Pro. Focus, please. Thank you. No, the Rev1 had no network. Right? It just had one antenna. There's no network on here. It's one trace that goes all the way to the antenna. Remember? So it could be that the network is in the radiation area. I don't know. But every board I've seen, and if you look at like the TTGo modules where they're trying to make they're trying to make this type of module out of the Pico, they've got their network as close to the antenna as possible. So, yeah. Let's go back to the heat. So, they get quite hot. Well within temperature spec, but hotter than I would like. I've never experienced a board so hot. I mean, my room 32s get quite warm when they're running, when the Wi-Fi is going, and they're going full on. So, one of the reasons they get hot is I've got no ground area on this, right? I mean, you can have a look. It is tight. I've got a bit of ground here. I've got a bit of ground here. I've got a bit of ground here. There's some ground at the bottom. Don't the routing on the back of this board is quite bad. I know that. It's already been fixed in the next revision. I should have had I shouldn't have crisscrossed power through the back here. It should have had a bigger ground area here. But the fact is, it doesn't matter. It's still tiny. So, yeah, look, David could be onto something there as well. Unfortunately, my revision 3 also has a network really close, so I'm not going to be able to test that theory. Although I'll go through what I've done there as well. So my revision 3 is a 4-layer board. I bit the bullet and I've gone 4-layer from now on. So any future versions of the TinyPICO is going to be with the 4-layer production. Whoops, just banged my desk. Which is a bit of a shame because it's much more expensive to make the boards. It's a longer lead time. It's a 4 to 5 day production time instead of a 2-day production time, which I know is not the end of the world, but you know, when you're sitting waiting impatiently for stuff. Right, so the 4-layer allows me to go smaller in my wires, and it obviously frees up a whole bunch of traces, and I don't have any of that spaghetti like this on the back. And what I get is a, excuse me, as close to full-size ground plane as I can get. My ground plane is going to be probably 250% bigger than what it is right now, which will give a place for the heat to dissipate to. Right, Sebastian, that's what I've done. Yeah. My revision 3's gone 4 layers. I was holding off doing 4 layers. I'd never done 4 layers before, obviously. It was a bit of a learning curve. I had a few submission issues with JLC with it because their documentation on what they accept, like what their fab stuff is for 4 layers, is very good, but they have no documentation on what settings in Eagle you need to do to match their capabilities, because all their names and all their wording for their capabilities is completely different to what Eagle calls stuff, which is a bit of a pain. So I had a few issues. I had a few false starts submitting Gerbers. I ended up having to write my own cam exporter for 4 layers and build my own DRC file for 4 layers to match JLC PCB, and I will be sharing those in a future. I've got a future video coming up. I just let everyone know I did a deal with JLC PCB for my revision 3. They're paying for my first 4-layer boards ever, which is great. And I'm going to do a sponsored by video for them, and I'm going to show everyone how I did my 4-layer stuff in Eagle, and then share all my DRC files and my CAM files, so everyone's got all the stuff they need to do 4 layers with JLC PCB. So, yeah. So I went to the dark side on going 4 layers, and I went to the dark side by doing a sponsored video with JLC PCB again. I know a lot of people here are sick of JLC PCB, but, you know, they're pretty good. Does the USB connector and any pins you solder on suck away any of the heat? The whole board gets hot. It's hot everywhere, right? And that's just because it's so small. Like, look at my thumb. I mean, that's. Oh really? JLC PCB are great. We won't even talk about the stencils. That's a sore point for me at the moment. Not their stencils. Just some chatter in the. It's not a sore point. Whatever. I'm a happy guy. Just some chatter in my Random Bytes video went a little bit left field. Yes. Oh, there's BLC, PCD. You can use those guys too. TinyPICO heatsink. TinyPICO. Yeah, well, so I can move my thumb now. As you can see, so this is tiny, right? So the whole board gets hot. There's no place for heat to go, right? The regulator gets hot. The Pico gets hot. Who wants to see how hot it gets? So we have a look. I mean, I'll show you how I'm measuring temperature. It's really, really bad. But I'm going to show you how I'm measuring temperature, because I don't have a thermal gun. I'll show you what I'm doing. It's pretty funny. I need to put some different code on it, because this is doing the sleep code. Actually, not that one. Oh, I've got some other news. I've got something else I want to tell you. This is really cool. I got some really good news. Look, what? How? Where is it? I'm very proud. I'm a very proud guy. Very, very proud. If I can find it. Where'd I put it? Here we go. Ready for this, everyone? This is also a Rev2 TinyPICO. Looks quite the same as my other ones, doesn't it? Except this one is D for dead. This is the first TinyPICO Rev2 that I did, and I plugged it in, and guess what? I got my first blue smoke. I've never blue smoked anything before. I plugged this in, and it went, and I went shit and pulled the cable out. And then I tried debunking what it was, and I haven't been able to work out what it was. I switched out the regulator and everything else. It was pulling power big time. It sizzled. I've never blue smoked a board before. So that was my first build. That was both demoralizing, but funny as well. I was very proud. So I've joined the Blue Smoke Club. Yes! Anyway, sorry, let's go back to this. So, I need to put some code on it. What I'm going to do is stick some Wi-Fi code on it. Just like a Wi-Fi scan. Because that's about as bad as you can get in terms of making this get hot. Because whenever it turns on the antennas and it scans, it's using maximum current draw on the Pico. It's pretty bad. So I'll show you what I do. Let's just port slab. Let's program it. No, it's not an ESP dev module. It is a Pico kit. Okay, let's run this. Do you have footage? No, I don't. I wasn't recording it. So I didn't do a record of the first build. You know how I did the Rev 1 build video? I didn't do a Rev 2 video build. I just wanted to build it and get it working. And yeah, I don't have the video. Oh well. Yes, blue smoke. Well, it wasn't blue smoke. It was white smoke, to be fair. It looked white. And I didn't let it run for too long. Like, I pulled it out straight away. So I couldn't even tell where the smoke was coming from. I just saw it smoking and yanked it. But I was very proud. I mean, I could try plugging it back in and seeing if it smokes again, but I don't want to do that. Okay, so this is just programming Wi-Fi code on. It's almost done. There it goes. It's resetting. Let's just bring up... I'm just bringing up my console just so I can see it's happening. Yes, live smoke. Okay, so this is now doing Wi-Fi scan. So, see, look, that just got -72 for my network here. Just sitting there like this, right? And this is the version that has the matching network on it. I mean, -72 is not terrible. Okay, my MacBook Pro only gets -59 to -65. So it's not terrible, but if I hold it like this, oh, you can't even see what I'm doing, I'll do it here. If I hold it here, like on this angle, I now get -80. Right? If I hold it like this, I get, hello, scan, -81. And if I leave it here, I get negative. So that's like when it shows you strength. So whatever the, decibel or dB, whatever it is, that's -72. Obviously it doesn't like being held near the camera. I don't know. So it's not terrible, but it's not as good as what this is, right? And it's logarithmic, so the lower the number, it's not like -100 and 0 is exactly even. Like, you know, negative 72. The difference between negative 72 and negative 70 is much greater than the difference between negative 5 and negative 6, or negative 7. Okay, so this is starting to warm up now. It's not hot yet. It takes a while, like, you know what I mean? Like, it's not like it instantly gets hot. I mean, that's no hotter than what my room gets right now. But if I leave it for a bit longer, it will get warmer. So I'll just leave it and I'll see if I can drink my coffee. Yes, so what I do to measure my temperature, it's terrible. So I went to buy one of those FLIR camera things that I can get temperature on. My God, $380. No, thank you. So I'm using my... Let's back out. I'm using this multimeter, my Exitech, and it's got... I've got a K-type probe, one of my... kind of like what I use in my oven, like what these ones, and I put it on C, right? See, it reads temperature. And I literally just stick it on the IC. This is my scientific temperature reading. You ready? There you go. And that's how I'm checking your temperature. Yeah, the problem with the laser ones, I took a look, I saw one for about $85. The problem is it was like 2 weeks to get to me. Yeah, I'm just touching the top of the IC, Rob. I'm not touching anything else. The ESP32 has a built-in thermal sensor? Maybe. You know what, I don't do a lot of ESP stuff. Like, I'm still, although I've got quite a lot of ESPs, but I'm an Atmel guy, so I'm still learning how to, can use it as a coffee warmer, probably. So as you can see, that's pretty, that's 47. It's been running for a while. Not the ones I've seen. Maybe there's a different one. The problem with the laser ones is the board's too small. I need to be able to actually directly, like, measure these individual, like, the little regulators and stuff. So it's 49. Okay, it's gone up to 50 now. And if I do it on the regulator, the regulator gets hot as well. So this is a max 500 milliamp regulator. It's not the AP2112. I've actually moved away from those because unlike the Room 32, these Picos, so what happens is when it turns the antennas on, it does a massive power pull of minimum of 500 milliamps. And I don't know how much it's actually pulling, but it's enough to brown out the AP21 2112s. So I'm using a different chip right now, and I've actually got some 700 milliamp regulators coming in my next order as well, just to give it a bit more headroom. A couple of K-type probes and a separate controller. Now, what have I missed? Probably depends on the brand, the retail anyway. Yeah, anyway, which regulator specifically? I'm using a SPX3819. You can look that up. And the new ones I'm getting, I can't tell you right now because I don't have access to my stuff on the other machine. So the 2112 is fine. I'm using the 2112 on here. I use them on my reflow. I use them everywhere. Like I've been using them exclusively. So, but the problem is there's something different with the Pico compared to the normal Room. And the pull that it does for power. So, okay, so here's the thing. When programming with the Arduino IDE, I get a brownout, when it's doing a scan, when it's turning the antennas on, I get a brownout 1 out of every 4 times. With MicroPython running on it, there's a brownout every time. The Wi-Fi can't be used at all. Who's buffering? Buffering. Yep. Sorry about the buffering. It's the low latency stuff. It's the... If we go low latency, there's a bit of buffering. So the 2112 is fine for the Room and the ESP32 and just general stuff. But the Pico, I don't know whether it's to do with the internal crystal or whatever else, but it's pulling the maximum. Like this is also a 500 milliamp IC, LDO, but this one doesn't brown out. and even with MicroPython. So I swapped out Matt's LDO when I met up with him at the MicroPython meet last week, and I hot aired swapped the LDO, and this one's also running fine with MicroPython. So they're very clear on the 2112 datasheet that it can do 500 milliamps, but it can do it for only a tiny period of time. So obviously the amount of time that the Pico is pulling it for is too high. What capacitor value I've got? So these have got... so the reference for the 2112 are a 1 microfarad on each side of the LDO. I'm actually using a 1 and a 0.1 on the right hand side. Hello Gary. But in my Rev3, which I'll show everyone the design for in a few moments, I've actually changed all this again. I've made more than just a 4-layer board change. So you can see here that there are two 0402 caps. The bottom one is a 1 and the top one is a 0.1. So with my, let me switch, how's that going? Ooh, getting a bit warmer. Let's just have a look again at how warm this is. And focus please. Solder whopping grade cap on the regulator output. Yeah, a whopping grade cap, because that'll make my board small, Julian. The idea is to keep the board small. Hello MJT. Cap values, so on each side of the 2112, oh, you guys can't see this, sorry, I just realised I zoomed out. On each side of the 2112, you're supposed to stick a 1 microfarad cap. Okay. So this is not terrible. I mean, the chip is, you know, it says 35 to 85 degrees in the data sheet. So this isn't terrible, but it's hotter than I'd like. And I'm sure, like, all it's doing is intermittently doing Wi-Fi scans, right? It does a Wi-Fi scan, it waits for 5 seconds or something, and it does another Wi-Fi scan. I would think that hammering the Wi-Fi might make it get super hot, but you're not going to be constantly hammering the Wi-Fi. I mean, anyone that's using a board of this size, they're trying to get it small and compact and probably running off battery. And if that's the case, you're going to, you know, you're going to sleep it. You're going to have it come online, wake up, do something, do a whole bunch of processing and go back to sleep. Or even if it doesn't sleep, do a bunch of processing and then you can shut the antennas down, right? And that puts it down to running nice and cool with low power. Gonna have to get a picture of thermals. Ooh, okay, let me have a look. David? I'm going to switch over to my desktop so everyone can see what we're looking at. Okay. Right, but that's not going to actually give me what the temperatures are. I need something that I can actually also... I want one of those cameras where I can see that and then like actually read what the temperature is from that thing. Yes, I have thermal wires, but it doesn't help because there's no ground plane per se. Hang on, I've just switched. So Tabletronic, so the problem is that there's just not enough ground area on the board. Like there's not even 25% of the board has got ground plane on it, including top and bottom, because it's 2-layer board. So that's why I've gone 4-layer. 4-layer, I've now got a complete ground plane. So having thermal wires to actually go somewhere is better than having a thermal wire that just goes, like, there's nowhere for it to go. Mention of onboard internal temp center on the SP32. Then like it does it. Okay, let's have a look. Let me show you what I have done with my revision 3, just so everyone's clear. Board load. Okay, so let me just, everyone see this? I hope so. Let me just turn off the bottom layer and ground. Okay, so go to my vise. So as you can see, I've now got a nice array of, why is that going there? Sorry, 1 second. There we go. I've now got a nice array of wires going to the ground plane. I've also given myself more room, slightly more room, with the matching antenna. The actual matching antenna is a little bit further away, although we're talking about like a millimeter. Problem with the Adafruit thing is also you have no reference video. Pause completely off. Give me paste privileges. What do you want to paste, Tabletronics? Oh, right, okay. Okay, you're a moderator. Be nice. Right, so this is my revision 3. This is the 4-layer board. So if I turn my my ground plane on, so my power planes pull back even more, but I'll turn my ground plane on just for now. Actually, I'll fill them both so you can see. Okay, and I'll turn that back off. So this is my ground plane. As you can see, it's massive now, right? Like it's got to be, as I said, at least 250% bigger than what it was before. And I'm hoping that, I mean, obviously it's still a tiny board. There's still not a lot of place for heat to go. But anything that's an improvement on what I've got now is better than nothing. As I said, this board is still running completely within spec. You know, under spec. Like, you know, as I said, the maximum I've ever seen it running when I was hammering Wi-Fi was 66 degrees, according to my probe, which is still 20 degrees under the maximum operating temperature of the chip. But anything I can improve on that's even better. Okay, let me just... Hello, Stephen. Okay, I'll have a look at this code, but I don't know if I'm going to do it now. Okay, I'll get to that later. That's for another time, I think. But thank you, Tabletronics, for that. And then with my power plane, I've actually made it even smaller. Just get it as far away as possible. Now, I could get my ground plane even further away from the antenna, which I'm planning, and I'm still trying to source a smaller button. There was one button that I found that was a right angle button and that would probably fit just in this section here, facing away. So I could actually lose, like I could get it, you know, probably 30% further away from the antenna. But they're out of stock and I haven't been able to find another place that has them that were less than like $1 each. So I don't want to commit to a button that costs $1 right now. Low cost real flow I found and works well. Seek thermal compact imager. Bit far away to let you borrow. I'll just pop over to your place in a few moments, David. Okay, I'll look at that. Look, the problem is I don't particularly want to spend hundreds of dollars on a temperature reading solution. Like my DMM, although it's far from accurate, will at least give me a good baseline. You know what I mean? Like with my revision 3, if I did the same test on the revision 2 and revision 3 and I see a drop of 5 degrees or 10 degrees, then I know I've improved it. Like there's only so much work I can do on a board this size to improve my thermals. Now the other good thing about going 4-layer is it's going to also help with my RF. So I'm hoping that potentially, right? And I'm saying potentially because who knows, I'll have reduced heat and better RF, slightly improved RF. Now, the matching network should be within the ground plane space, but again, I was conflicted between all the references I've seen having the network as close as possible to the antenna, but still within the ground plane, and not having the ground too close to the antenna. So revision 3 is still going to be an experiment, right? Like I'll be upfront and say that revision 3 is coming panelized, because that's what JLC PCB have done. So I'm going to get a lot of boards, and it's not going to be the final revision. So if people want to start throwing wastage stuff at me again, whatever. But that said, revision 3, yeah, it's not going to be final. It's going to be just the next step. If my worst case scenario is I just get to improve thermals, and my antenna doesn't improve at all compared to the Rev2 just as a one-on-one comparison, then that's fine, because as I said, I've got this guy Chris, who hopefully I'll be able to work with, and he'll be able to give me a much better idea on how to improve the network. One difference that I did on 3 that I changed on 2 was my trace width from the LNA pin to my matching network, or to the antenna, was a different thickness on revision 1 than it was on revision 2. I've made them both the same thickness again. Radiation pattern antenna like that is perpendicular to antenna, almost no signal comes out the ends. So switch probably isn't affecting much. So I'm just reading back on here. I use mine far more than PCB thermals helped me find heat loss in the house. Wow, okay. Wow, that's pretty cool use. But yeah, $200 US. It's probably a little bit, that's like $320 for me right now. Yeah, it's a little bit steep, I think. Now the switch probably isn't affecting it a huge amount. I didn't think it would. As I said, I've seen other reference designs or other designs where there's stuff as close to the antenna as this switch. Although this switch is pulled high all the time. It's the reset switch. So technically there is power coming through to it. But yeah. So that's my revision 3 board, which, let me just, I can't get to my keyboard. Okay. And then if I actually, let me just show the back. So I managed to clean the back up stacks. As you can see, I mean, this is signal routing, it's fine. And not that it makes any difference now. But I managed to also get these traces further away from the antenna as well. The U-caps are right in line with the radiations. They probably couple some signal back. So this layout is exactly based on what I've seen other boards work on. It's a version. It's basically what we discussed last time. Hello, Agim. It's what we discussed on the TinyPICO stream last time about placement, but this is pretty close to what other. Let me just change over. What other implementations are doing. So yeah, I don't know enough about radiation or placement. You know, that's going to be a all I know is without the decoupling caps it was working better. Why is it so dark in here? Yeah, I don't know who's correct and who's not correct, and I don't know the right way and the wrong way. I just need to put it in front of someone who can measure it, right? Like, so I've been trying to work out how to measure impedance. I would move the antenna feed to the lower cap. Okay, well, I mean, Sure. It's revision 4 thing. Well, yeah, I'm not sure that just moving like the feed's going to make any difference right now, though, Peter. Like, I think, as I said, with the network right now, it's worse than without it. If I take all of this off and just bridge this one here, and if I just bridge that, my Wi-Fi works better than if I have any matching network. So I think it's going to be a lot more than just moving a trace or thickening this trace or whatever. I think there's it's definitely yeah. Yeah, anyway. I need someone who actually understands this better to look at it and, you know, and be able to experiment with me. I think that's going to be key. I think, you know, no offense to everyone, I think people telling me you should try this, you should try that, they're like random suggestions that are based on no data, you know what I mean? I need someone who can actually grab the board, knows how to measure what I've got, and knows what changes are going to affect what, and be able to do it with me. Like, we can sit there and go, okay, well, we've made this change, let's measure it. Not me measuring like this, right? In the air with a Wi-Fi scan, but actually measure it properly with a spectrum analyzer. And is the ant hungry? Feed ant. Feed the ants. So anyway, that's my plan for that. I think everything else is just going to be pure... It's going to be worse than guesswork. That's what I was saying before. So I'm trying to work out... I'm trying to find a way to measure impedance. I found an interesting article online about how to kind of ad hoc measure impedance with a scope and an inline... Not an inline, and a resistor, a bridging resistor. But I haven't been able to get that working on my scope for some reason. So, should antenna traces be curved? Yes, ideally. What? Curved antenna traces? I've not seen a curved antenna trace in any reference designs I've seen so far. I mean, yeah. There's so much information about this stuff. It's kind of crazy. Let's go back to the camera. I should also mention that when I was measuring the power usage before, I have no idea what size shunt resistor is in my multimeter. So that's going to affect what my readings are on my current draw when I'm testing. Sorry, I'm still a bit sick. So again, I don't have any, you know, like I'm doing inline multimeter to test current, which is not an ideal way of testing. If I had a better accuracy on my desktop power supply, it would give me a better result, but it just shows me 0 milliamps because I can't get lower than 0, which is, yeah, a bit annoying. So that's my Rev2. It's pretty cool. I'm very happy with it. I'm going to stick to this size. Like, I'm hoping I won't have to go bigger again. It'd be nice if I can get this working as good as possible. Linked to 2 caps. Probably missed why the antenna is linked to 2 caps. Dealing with whatever will actually bounce down the trace, so curves present the least resistance. Sure. No, I understand that. I just have not seen that anywhere. I haven't seen a curve on any implementation so far. I mean, ideally, a straight line would be best, right? But I don't have a straight line to the antenna. Again, so there's 2 caps and an inductor there. It's called a matching network. There's different combinations of it, but the idea is the antennas are 50 ohm impedance, and the idea is to match the 50 ohms on this side. So your electronics on this side going to the pin, to the antenna pin, should be a matched 50 ohms to the antenna. So that's what this network is designed to do. Well, it's supposed to do. In this case, it's definitely not doing it. And I have no way of measuring what it is doing. Yeah, ESP datasheet. Which ESP datasheet? The Pico datasheet? The, yeah. As I said, I've not seen a curved trace implemented on a board. I've been looking at implementations on board, not on schematics or datasheets, because that doesn't mean anything, right? I mean, having it on a schematic or in a datasheet and seeing what people are implementing are completely two different things. And there aren't many Pico boards out there. So, maybe plan on adding an antenna connector. A ULF? Probably not at the moment because there's no place for it. It's something that potentially... check out the feed here. I'm not looking at any of the ESP. I'm only looking at Pico reference. Just to be clear, okay, there's a million versions of everything else out there, of all different combinations. I'm looking at Pico reference specifically right now. So, Peter, what is this? Look at this feed. I don't know what this feed is. Right, okay. Sure, okay. I mean, yeah, we can, I'm not going to, but I can pull up other pictures of other reference I've seen, including TTGo, that doesn't have a curved trace. I totally get why there's a curved trace, that's fine, and I can change it to a curved trace. But I think at something this size, a curved trace and the little bend I've got right now is not going to make a massive difference. Should it be a curved trace? Maybe. Oh, kebab, yum. Hello, Neffers. Pico. It shows a successful network, does it? Right, except which components are being used and which ones aren't. That's a nice picture. So, do you have a picture of that that's got the actual, like a photo of the finished thing? Because every picture I've seen of implementations have got empty pads on the networks and unidentifiable values on components that are in there, right? So, you know, this is the struggle I'm having. Like, you know, I appreciate everyone saying do this, do that. You know, I haven't spent 5 seconds looking at this. I've spent weeks and weeks and weeks finding as much reference as I can. And, you know, every implementation in the schematic is different to in its final implementation on a PCB that I've found so far. I play with the bottle to swap positions of the button and the antenna. Move the antenna out of the matching network away. Sure, I can. But once again, look how close the matching network is. Hang on. I mean, look how close the matching network is to the antenna here. Now, Peter, I appreciate it, Peter. I get that. But this diagram doesn't show a completed matching network, right? That's what I'm trying to get at. So you look at the TTGo board using the Pico D4, and they have a layout, and they're only using one component on their 3-component matching network, right? So the layout, okay, the layout's important, but look at how close it is to the antenna. So clearly having the matching network that close to the antenna isn't necessarily a problem. Maybe the orientation of? Sure. I can change it. Like, I just... Yeah. The problem I've got is I can make a change, I wait a week and a half to get a board, I build it, and I have no way of really identifying if it's better or worse other than stupid tests of holding it up and spinning it around and watching a Wi-Fi scan. And every change I make is not an educated change, it's a guess change. Right? So, every time I make a change that's a guess, or I look at that image and I go, yep, I'm going to make it look like that, but then the version I've got right now looks like something else, and that didn't work. I try like this and it looks like that, and it works better, it doesn't work better, and I have no idea why. I'm just going in a circle, and I'm just going to keep making more boards, and I'm going to get to revision 10, and I'm going to have no idea why stuff is working or not working. Does that make sense? So, you know, here's an example of a layout that maybe works, and I've seen other examples of a layout that looks different to this that apparently works, and some of them have components on them and some of them don't have components on them. You need to practice your black magic. The best approach is to talk to your contact. Well, that's what I'm waiting for. Unfortunately, yeah, he's only back this week, so I might get to speak to him this week. It may be next week. Yeah, it's... Sorry, I apologise. I'm frustrated, not with everyone here. I'm just frustrated because this is a... I mean, I said from the start, it's way out of my knowledge depth. And, you know, it's not even a cost thing. It's a slow thing. Like, I'm not going to get my revision 3 boards till next week now. You know what I mean? Like, we're talking about potential changes, yet I can't even try my revision 3 till next week. So, you know, this is not going to be something that's going to get solved quickly. And as many of you know, I'm kind of impatient. It's not that I'm impatient, but I like moving at a fast speed. And this is really slowing me down, you know. And there are things that I can do, and I know that this change is going to do this effect. And then there are things that I can do that I have no idea what the result's going to be. And I hate that about this process, the RF side. I'm pretty sure I'm not going to be able to CNC a PCB like this. Not going to help. Are there 5 GHz antennas? I have no idea. I don't think so, because none of these support 5 GHz. These chips, they're all 2.4, 2.45. What's next to impossible? Yeah. Impossible to do CNC or anything of this size. So, not really an option for me. And it's vacation time. Oh no, I'm going to Shenzhen in November, but that, again, it won't help me. There's just time and lead times, and now that I've moved to 4 layers, it's going to be worse. Because the manufacturing times are slower. Where before I could put a board into manufacturing on Friday, let's say, or over the weekend, and potentially get it back next Sunday from DHL. Now, it's a 4-day production time. So, it's gone dark in here. It's turn a bit brighter. So now that's slowed me down. I'm now looking at a week and a half turnaround on boards. So I'm frustrated. I apologise, Peter. I really appreciate your help. Everyone's help. I just feel like it's pulling me in different directions, and none of the directions, I can't quantify results from any of them anyway. Flow like water through pipes. I'm just saying to point you to the information that shows the clearest path. Sure. I appreciate that, Peter. I mean, there's nothing I can do for revision 3, because that's already in manufacturing. I've already got a revision 4 board that I'm working on, but I'm reluctant to make any changes to it, significant changes yet, because I don't know what changes to make, right? At least show confirm that the coupling network is okay. So this image you sent me, Peter, is there a website that matches this for this particular board? Like, is this module, is this something that is available? Is this something I can grab and pull apart? You know what I mean? Show confirm that the coupling network is okay. So how do I do that, David? I don't have the tools to know if my coupling network is okay. I've got no way of, I can't even find a way of, you know, of calculating the impedance on here, of measuring the impedance of that side of the network. So I'm not even sure how I do that. Signal strength should increase. Right, except everything. And trace anti-strip. Is the coupling difference? I just grabbed that pic based on my knowledge of what RF layout will work first time. Okay, I need to track down what this product is though, because as I said, I need to know which of these components are being used. I can lay out like this, that's fine, but without knowing what's being used here, it's still going to be a matter of me sitting there and putting components on and off and trying every combination and adding extra solder and extra this, and you know what I mean? Like and even doing that, I'm not going to have the tools to really measure how it's improving. As I said, I held this up. I held this up and I was scanning, and every time I scanned it was a different result. So, you know, I've got no way of recreating an ideal, what's the word? An ideal test scenario that's going to, you know, every time let me just go back to so let's say I'm here, right? And I pull this off and I make a change on the network. I solder something in, or I change something around, and I plugged it in, right? And I tried it again, and this time I held it here, and the next time I tried, I held it here, and the next time I tried it, I held it here. I'm going to get a different result every time that has nothing to do with the components. It's going to do with where I'm holding it, right? Where my finger is, over here, you know what I mean? What's happening in my office at the time. So, I've just got no way of measuring accurately. Sorry, as I said, I'm frustrated. I feel like I'm getting so close, yet the one major thing that kind of makes the board, that's going to make the board the most successful, is something that it completely eludes me right now. Like I don't have the skills to be able to solve. Not many electronics YouTubers will be able to help you with this. Maybe the signal path. Yeah, well, the key thing here, though, Julian, is there are lots of knowledgeable people out there, but having someone not here with me, with a board in their hand that can actually, with a spectrum analyzer or whatever tools they need, they can actually work with me on this, it doesn't help me. Like, you know, sending one of these to Andreas Spice doesn't help me. You know what I mean? Like getting other people's input is great, but you know, I need a hands-on solution to debunking and working on this problem. Does that make sense? The type of antenna will definitely make a difference, Des. Who's that guy on YouTube building and testing Wi-Fi antennas? I don't know who that is. So this is still a ceramic antenna, but it's still a 2D antenna. If I went for a 3D antenna, like one of the Molex ones, that'll help. Or, you know, the metal shielded, the metal antennas, they're 3D as well. That will also help. With a metal antenna, I can actually get the components right next to it. I can even put components underneath it. I've seen implementations with those metal antennas where the matching network's underneath the antenna. The problem is those metal antennas are 5 times the price of this one and considerably bigger, and my board's going to have to increase in size again. Right? I need to try to maximize and optimize this type of solution as much as possible. I can get a smaller ceramic antenna, but again, triple the price. I reckon searching antenna would lead you to him. With metal antenna, they put the network underneath. That's right, yeah. So the metal ones, you can put the network underneath. It's, you know, all different options. Like they talk about on this antenna on Rainstone, they talk about a 5mm clearance. Right, now this has a 5mm clearance. This has a 4mm clearance. You know, maybe that extra mil is what's needed. And my Rev3 has a little bit more clearance than the Rev2 does. You know, maybe it's that. I don't know. Yeah, I don't think it's the antenna specifically that's an issue. This ceramic antenna is definitely better than using a PCB antenna, but they're both still 2D antennas. So yeah, I'm in a, see that's still, I mean this is still running Wi-Fi. Like I feel that and I go, okay, that's hot. But it's not hot. Just gonna measure it again. Let's see what it's running at. Now obviously when it's running MicroPython, it gets hotter. Because MicroPython, just because it's interpreted, like it's running its bytecode, it's going to get hotter, and it does. So it's getting close to 50 now, and this has been sitting here for a while, just scanning Wi-Fi non-stop. I think your largest problem could be the capacitance between LNA pin and the ground. And the ground port. Well, Peter, that should improve with a 4-layer board, right? Or potentially. Okay, it's up to 51. So I can't remember what time I started having this scan. 52. I mean, this is very not scientific. $54. It's still slowly rising. Anyway, I'll stop doing that. It'll probably get up to about 56. But that's, as I said, that's hammering Wi-Fi. Let me just go back to here. So what do you mean, Peter? Capacitance between LNA pin here and my ground port. Well, this is obviously this is the 4-layer board. So I don't have, so on my, let me load up my revision 2. So we can look at the revision 2 exactly to see what's going on. Okay. Let's turn that off. Let me do a fill. So you're talking about capacitance here between the trace and the ground. Okay, so everything that, well, everything. So documentation that I've seen online shows that there's supposed to be ground on each side of the LNA pin if it's not underneath. More clearance, you think? Okay, well, this gets completely solved with a 4-layer board, right? Because then the ground plane's underneath, which is still going to be capacitance, but there's going to be pre-preg between. That's why I'm hoping that a 4-layer board's going to improve RF, because it's not going to form capacitance sideways, but potentially underneath it still will. The thing is, it could be, excuse me, it could be lots of things, right? It could be a little bit of capacitance here, it could be wrong orientation here, it could be some radiation here, it could be antenna thickness here, it could be just wrong components here, it could be the network too close to the antenna, you know what I mean? Like it could be 6 changes, 6 little changes that make a tiny bit of difference everywhere, and some of them make it slightly worse and some of them make it slightly better. Right, it's about 8 things at the same time, and that's if my hair was longer, I'd pull it out of my head. Okay, the Wi-Fi. It's a Wi-Fi used for beyond prototyping where the Wi-Fi hub is in the room we're close to. or you want to use it in the final applications between rooms around the house. Well, the Wi-Fi should be for whatever anyone wants to use it for. Like you know, a lot of people use their ESP32s or A266s for things like sensors. Like they'll have put a sensor on there, like a humidity or temperature sensor, and then have the board connect, you know, every little once in a while to their network, to like an MQTT server or something to log some data. Could be for data logging or something, right? I don't know what people use their stuff for, their Wi-Fi stuff. I've personally never really found a use for any of the Wi-Fi and any of my boards other than doing things like displaying stuff on a LED panel or something, like what Brian does on his, you know, Brian Locke does on his channel, on his streams. Like, but I know a lot of people use them for logging, so it doesn't have to go 30, 40 meters. Like most of the use cases for something like Wi-Fi, I would think, would be fairly close range. And I think that if you're trying to do longer range Wi-Fi, then you wouldn't really be looking for something like TinyPICO. Like, I don't know, you'd want something that was either had an external aerial antenna, or that was much beefier, or, you know, or move to something like LoRa. It's not enough gigawatts or too much flux capacity. Yeah. I know it's complete dark art. Like, absolutely. Doesn't mean it doesn't frustrate me. I guess what frustrates me the most, right? And I'll be totally honest. I'd be less frustrated if this implementation was terrible and this implementation was terrible but slightly better. Right? Then I'd be going, okay, I didn't put a matching network on here and that's crap. I did put one on here and it's a tiny bit better, but it's still not good. Let's improve it, right? But the truth is, this outperforms my MacBook Pro in Wi-Fi connectivity, right? And that's what drives me nuts, because that goes against everything. It's totally no matching network, right? Capacitance on each side. If you're worried about capacitance, well, this has only got a little bit of capacitance, right? I mean, there's just so many things wrong with this, yet it outperforms every other Wi-Fi antenna, connection, whatever I've got in my house. In case you haven't seen this, it helped me a lot to understand inductance issues. Good, bad, and the fugly. Thank you. Okay, I will. I'm going to bookmark that right now. Yeah, I like Bill's stuff. Big fan of Bill because of the his Commodore days. Yeah, he does some really cool stuff. I'll definitely have a... How is that the one I just watched? I think I just watched that. Anyway. Going to redesign boards for other Wi-Fi devices. Going to redesign for my other Wi-Fi. What do you mean? What do you mean, Azzy? Yeah, Bill's an interesting character. Sometimes he just waffles on, and he's hard to follow. My router, computer, etc. Am I going to redesign? You want me to redesign my Wi-Fi in my computer to make it better? I don't think so. I don't think so. I think I'm not the qualified guy to be doing that. Yeah, still getting warmer, I think. So look, I'm happy with the board in terms of its size now. I just need to keep iterating and improving, and it's a slow process. Suppose you really don't need the matching network. You have very short distances. Matching use primary needed to push most of the signal to the antenna. Right, but Peter's reference picture is pretty small as well. I'd say it's about the same type of distance away from the antenna as what I'm using, and they've got a matching network apparently implemented that seems to work. It could be that I don't need it. I don't know. It's a not an easy thing to try though, right? Like, as I said, just bridging it, like I did here, doesn't make it the same as this one. Because I'm still adding extra impedance into it. Thanks, Neffers. Just tiny donation. Thanks, buddy. Appreciate it. Different design antenna, sure. I think there's something that should use one of those small heat sinks on the IC. Putting a heatsink on the IC is one thing, but again, I'd like to reduce the heat as much as possible to avoid having to do that. But the truth is, just the board size just again gives no place for thermal to go to. It's a size thing. You know, as I said, my Room 32 gets hot as well. Not just this one, on my WeMOS board as well, my Lowland board. They get hot when I'm spamming the network, but obviously not as hot. About 10 degrees less than this, but that's shielded, right? So I'm measuring the shield temperature. I have no idea how hot it's getting inside. Crazy idea. I could develop an antenna shield, but I don't have an antenna pin, right? So an antenna shield won't really help. And to put the antenna onto a pin so it can go onto a shield, all I'm doing is massively affecting the impedance of the antenna line. So it's not I don't think making an antenna shield is a good idea. It's not the type of thing you can really do on a shield, I don't think. You know, if I could solve the button, or just got rid of the reset button maybe, I don't know, then I could potentially stick a ULF connector over here. But they're pretty big. Here's a little one. Here's a little one just on a feather. So you can see here, so it's about the size of the button, the switch. I'd have to lose the switch. And it also needs to go right over here next to it. Like, you know, I can't have a super long trace going from one end to the other end. So, of course, if I got rid of the button and I moved the antenna over to here to get it away from the matching network, then that could potentially help. But the documentation says that the dot needs to be in the corner. So if I was to move the antenna up, I'd have to change its orientation and get it over here, which would give me a pretty long trace for the matching network to the antenna. So, itty bitty chippy committee. See you later, David. Thanks for joining. What did I just miss? Hang on. Design antenna, totally different characteristics. Perhaps it needs a network. Even a copper shim attached to the IC would help. Oh, hang on. Chris is focused on putting a heatsink on the chip. May not be able to prove. Yeah. Well, I can definitely improve it to get it back to this somehow. I hope I can. Sacrifice a GPIO pin. Can you hold the Rev2 next to the room? May give us a better reference for how... Sure. It's almost the size of the room. And let me just grab this. Hang on. Here's the D1 Mini. So, quite small. You could use a Wi-Fi connection and then a small antenna attached. And that's the TinyPICO with the D1 Mini. That's pretty cool. So like in terms of size, like it's you know, I look at it now and it looks massive. But it's not, it's really not. Like it's the size of my thumb. It's actually smaller than my thumb, I think. Yeah, it's smaller than my thumb. There you go. It's pretty cool. But yeah, I've done myself into a bit of a hole by making it so small because thermal and potentially Wi-Fi quality. Because in how much more functionality the TinyPICO has compared to the room. Well, yeah, like I squeezed a lot in here. Okay, so one other change I should mention on my Rev3 desktop again. Let's close that down. Let me load my Rev3 up. Is I also reduced the amount of components on it. So I feel like I went a bit overboard with components on my Rev2. And I've taken off everything I feel like I don't need now. Excuse me, let me just turn off. Okay, so the first thing is Chris found a new twin NPN transistor package over here that has built-in resistors for biasing. So I don't need the resistors on each side of the... I can get both at the same time. Where's my cam? Oh, okay. Hang on. I'm just rearranging my screen. Oops, that didn't work. Won't be a second, folks. Sorry. Here we go. Just wanted to show you at the same time. So, let me get this closer if I can. Because it's small. Focus. Right, you might be able to see, maybe. Oh, who's going? Someone's going. See you later, Des. So this, you can see here, there's two little resistors on each side of that package. I don't have a model number, Sebastian. Sorry, off the top of my head. So I managed to drop those two resistors because this new package has built-in bias resistors. So that's two little 0402s that I don't have to put on the board. I've also dropped finally my discharge resistor because it's just not worth it. It's not needed. And Dave Watts should be happy. I've finally removed the enable resistor on the LDO, and I'm just hooking it up directly. I've also got rid of the 0.1 microfarad cap on the way out of the LDO. Because the fact is, all of the power already has 0.1 caps on it. So 0.1 caps over here, I've got 0.1 caps on power on the... oh, sorry, you can't see that. I've got 0.1 caps down here, coming into the Pico. I've got 0.1 cap over here on the CP2104. So having an extra 0.01 over here was just not worth it. Yes, that's the one, Chris, thank you. So I've gone through and tried to reduce components count on here just to make it easier for me to build. Less components to put on, less time to build. And I also spaced some of them out a bit. I had my LEDs and my resistors too close together. Very hard to place. From USB, so does anyone really need a button? I use the button occasionally to reset the board if I want it to restart. The only other way to do it is to like reprogram it. So I occasionally find it useful to have. Doesn't have to have it. I guess I could always just pull the reset pin low. I mean, I've broken out the reset pin. So I could technically lose the button. The reset button isn't there for programming because I don't have a program button. It's really there just to be able to reset the board. Also, what happened if you dropped having it? Oh, okay. Yeah, I could drop the button. Assuming that the button's gonna, is interfering with the antenna, right? If I drop the button, I could potentially put a ULF connector on. Although I'd have to source them and work out what they cost and work out how I'm going to mount them. Pretty small. But yeah, I could do that. Sure. Revision 10, anyone? I've also thickened up my power coming in from USB. Quite a bit actually compared to what, quite a bit from what I had before. I'm hoping that, because obviously when it's running off battery, it's nowhere near as hot. Obviously the voltage is lower, and although the current draw is the same, it's good 5 to 10 degrees less. Rev 100. It's a good 5 or 10 degrees less when it's running off battery, and so I figured when it's running off USB, so I just realised that it's not the powered one. Whoop. That I've thickened up my traces just to try to allow more heat to sit there. Rev 304.28 version 14. I hope it doesn't get to revision 100, but I'm pretty sure it's going to get to revision 5 at this rate. I think revision 3 is going to be about power dissipation. I really didn't change a lot else to do with the antenna on purpose because I didn't know what to change. So it's going to be about better thermals, I hope. Fingers crossed. And then I'm hoping that my revision 3 is what we'll be able to work on. Because it's going to have a better ground plane, it's going to be, I hope, easier to work on the RF, and then we'll be able to, we meaning myself and this guy Chris, or someone, whoever, will be able to have a more of a solid plan on what to do on the network, matching network, and then revision 4 will be about improving RF. That's what I'm hoping. Fingers crossed. I've already started working on a test board for this. Just laying out something that I can plug the board into to test all the I/O and everything else for a manufacturing, like a jig, to be able to just make sure that every board that I'm making works. And the key to that was obviously finalising the size of the board and the pin layout of the board. Yeah, I'm not sure what else to cover on that. That's pretty much everything, I think. Go back to the camera. Look at the Pico. Plug the battery in. Where's my battery gone? Xeon Industries. Yeah, it's far from Xeon Industries. Average spins to reach production for a complex product layout with similar constraints in the commercial world is 9. It's 7 with Altium. So Altium makes it better, does it? Do I need to jump ship, do I? So to ask, but I missed the revised power path bit much earlier on. Wait, what have I done? Xeon's dynamic. I wish Xeon was less impatient. Come on, sit. The battery's not gonna behave orientation wise. Oh well, whatever. Dumb question. What does the board do? Thanks, Julian. Really? What does the board do? The board is a full ESP32 implementation. So it's a development board. It's a prototyping board, I guess. It's a microcontroller board with 2 cores up to 240 megahertz with onboard LiPo charging and Wi-Fi and Bluetooth. Blinks an LED. In this case, it just blinks an LED. Right. It's a development board like any other one. That's like a Wemos board. Like it's a Feather, right? Here's a Feather. It's got Wi-Fi on it. It's using an at-win Wi-Fi. It's got LiPo charging, and battery and it's a broken out board, you can do what you want with it. You know, I mean, not everyone out there has the ability to build their own boards with their own microcontroller chips on it, so people buy development boards that they can use in their projects. And that's what TinyPICO is. But TinyPICO was all about making it as small as possible without sacrificing anything. Well, clearly there are a few IOs I haven't broken out, not many. And the Pico D4 is a bit different to the ESP32, the WeMOS, because there are some IOs that you can't break out. They're reserved for SPI flash. So pins like 16, 17 and stuff like that, which are broken out in the room, you can't use. They're restricted on the Pico. But other than that, it's supposed to be a tiny development board that does everything that this does, type thing, but with battery. So it's not a dumb question, but yeah. Apparently development boards are a big thing. Apparently. LTM has some awesome simulation. You're doing amazingly well with. Thank you, Peter. Although there's some new simulation stuff in the latest version of Eagle 9.2, which I haven't looked at yet. Where unexpected is made. Sorry, I'm just going back. When I bought my Apple Watch, some of my friends asked, can you browse web pages on it? Well, probably, but that's not... Yeah, browsing web pages on the watch is a bit small. The whole board is smaller than a Z80, Julian. I don't know. I think a Z80 is more fun. Yeah. I mean, I was challenged to make the board as small as possible by Matt, obviously. And the challenge has been great. I mean, the worst that comes out of this, let's say I can't get the RF good enough, or I can't get the heat good enough, or God forbid I don't ever release the board. Oh, God, I don't even like that term. Heaven forbid I don't even release the board for whatever reason. I've learnt a stack doing this. So this is all about my journey, right? About learning and improving and building my skill set. One thing I did on this board as well, and you might not be able to see, you can just make out the pins around the Pico. I rebuilt the footprint on this because if you look at this one, you can't see the pins. Pretty much you can't see the pins. You definitely can't see them on more than one angle at a time. Very hard to rework a QFN when you can't get access to the pins. I mean, holding the iron next to it may work, may not. So I built my own footprint for the Pico on revision 2 that's got slightly different shaped pins, so I can actually get access to them now. Excuse me. Thank you, Stephen. Yes, I'm actually really happy with the layout of this board, but I've simplified it for revision 3. You know, like, I'm not sure you can see, but this resistor and this cap next to each other, yeah, I couldn't even place them. I had to roll the resistor into place with my tweezers. Because it's too small. It's ridiculous. I made it hard for myself on this layout, for sure. David Watts, are you going to get stuck in the ever smaller loop with all your projects? I found myself falling into that. I'm just limited to hand soldering at the moment. I don't know, I don't see how I could make this smaller, so I'm not going to try to make this smaller anymore. The only way I can make this smaller would be to remove the charge circuitry and do that as a shield, which was my original idea. And I could probably... don't think I could reduce the width, but I could probably reduce the length of the board by a little bit. But I don't think it's worth it. I think it's diminishing returns now, David. Since dev board and a nice pin width of prototype board, length might not be as important. Perhaps your PC antenna wouldn't be a bad idea, as it saves the cost of a ceramic one. Yeah, but the PC antenna is actually quite... yeah, possibly. It actually wouldn't add that much room. I'd probably only have to make it maybe 1 millimeter wider. So I was just checking how old it is. I'd probably have to only make it 1 millimeter longer to be able to fit the PCB antenna. The problem with the PCB antenna is that apparently it's not as good. As a 2D antenna goes, a ceramic is better. And these are cheap. These are like $38 40 cents each. You know, I know it's more than free on a PCB antenna, but it's not like it's $3 like a Molex antenna. The QFN needs 2-3 mil around for rework, if you want that. Yeah, well, I've added, I don't have 2 or 3 mil, but I've added enough that I can at least touch it with the iron now, which I couldn't do before. So what I meant was, are your projects going to be pico size from now on? Oh, my projects, I don't know. I don't even know what my projects are going to be. No, I don't want to do everything tiny, although I look at this now. And you'll know more about this on Friday. Just letting you know now, there's an unexpected video result coming on Friday. Anyway, I look at this now and I think, wow, that is chunky. Look at all those massive, look at these massive components on here. Like, surely I can make this board smaller. Part of me wants to make it smaller, but I don't know. We'll see. And I keep missing stuff. If the Pico needs 50 ohms and antenna's 50 ohms, they're matched. That's your Rev1 works, Rev2 doesn't lose the matching caps. Hello, Eddie. I don't understand. If the Pico... Stop scrolling, chat! Hang on, the Pico... They are matched. Well, they may not be matched in Rev1, but they're closer in Rev1 than they are in Rev2, for sure. Yeah, I'm not putting any components on the back. Sorry, not going to happen, apart from the JST connector. Now, also, I've ordered some, which haven't shipped yet, some smaller versions of the JST connectors, but they're non-standard. So I've ordered both the male and female ends of them, but every battery I've ever seen uses this size as a standard. So I'm not happy about putting a smaller connector on the back here to reduce this size when it's non-standard and no one's going to have batteries that fit. But other than that, I'm not planning on putting any components yet on the back of the board because it's an assembly nightmare. Like, it just adds complexity for me that I don't need right now. But I've covered that already in previous videos. What did I miss? Hey, Mike. Hope you're watching the stealth again. Great stream. Oh, are you going? Catch you later. Thanks for lurking. Sometime when you're able, would like to talk you offline on future product ideas. Is that to me, David? Sure. Happy to chat with you all the time. By the way, my PCBs are stuck in China holiday. Yeah. I knew they would be. Everyone's PCBs are stuck. China. Yeah, I think David Watts has been super busy at work this time of year. Cool, yeah, I'm happy to chat with you offline, David. All good. Like, I'm impressed. I've impressed myself, I feel, with this board, especially Revision 2. I think Revision 1 was a bit of a hodgepodge of getting it together. It was really about picking the right components and getting it working. Revision 2 is even though I got Wi-Fi, like RF strength issues and obviously thermal issues, although they both have thermal issues, I really feel like I jumped up with Revision 2 in terms of my power path and my not so much the neatness. I mean, neatness is always nice on a PCB, but just the layout, the structure is much improved on Revision 2. So for worst case scenario that it never goes anywhere, I think I've done a really... I know I'm tooting my own horn. Woo-hoo. I think I've done a really bang-up job on going from Revision 1 to Revision 2. It wasn't just about making it smaller, it was a complete redesign. See you later, Stephen. Take care. And brownout issues? No brownout issues at all. Now that I've moved away from the 2112, AP2112, I've not had a brownout issue. But as I said, I've got new LDOs on the way that are 700 milliamp. So it gives me more headroom. So the problem with using a 500 milliamp LDO is that the Pico can pull 500 milliamps, which means if I've got other things connected to this, I've got no headroom. So I'm definitely going to be moving to a higher rated LDO. There's not a lot in the higher than 500 milliamp range. I mean, there are, but you suddenly go to either very expensive LDOs or you go to LDOs that have much higher headroom, but a much higher quiescent current. So, you know, it's a yeah, it's, what's the word? I can't think of the word. Like, it's you win and lose. It's a compromise on feature set, so I have to, yeah, I'm going to play around with this new one and have a look at it and see. I don't know if I saw silk on the back side. Make sure plus minus is clearly marked for the JST. There's no consistency on battery connections. Really? No, I don't have anything marked plus or minus on the back of the silk. I have not seen inconsistencies on batteries, not the ones I've bought. I mean, admittedly, I bought all of mine from Adafruit. They're all got battery protected cells. Like if someone wants to use cheap Chinese unprotected ones, that's on them. But I did not know that there was inconsistencies. Thank you for letting me know. I'll have to, well, it's too late for revision 3. I'll have to do it in revision 4. Stick a plus and a minus on there so people know. Okay, I'll make that clear. Thank you. You said earlier that the Pico was 50 ohm antenna and the other antenna is 50 ohm. They don't need matching. No, they do need matching. That's not how it works, Eddie. The antenna is 50 ohm. So everything from the pin to the antenna also has to be 50 ohm. Right? Both the antenna's 50 ohms, so therefore the electronics has to be 50 ohm as well. It's supposed to be matching. 50 ohms each is what they're supposed to be. So the Rev1 works, well, they both work fine with Wi-Fi, but the Rev1 is stronger because clearly whatever I've got here is closer to 50 ohms than what I've got here. Does that make sense, Eddie? Yeah, you don't say no, like you're supposed to have 50 ohms on the left side of the antenna as well. It's got to be matching. Definitely have different polarities also when you get the fly beads. They can be swapped around. Flight leads, right, okay. So you've done an outstanding job on this board. Thank you very much. So I didn't toot my own horn to get other people to tell me I did a good job, so that wasn't the point. I'm just, honestly, I look at this board and I'm impressed. I'm impressed that I actually managed to assemble it. Can't wait to use my microscope. I see people get that from that fat trace, I would hope. A good shot out on the silk string. Yeah, I don't think the trace is enough. You're right. Well, actually, no, there's no real... Yeah, I mean, there's the... There's a trace going to battery. Yeah, but that's not enough. It's not clear enough. I definitely think I need to mark it with a plus and a minus. I will. Now, the other thing is, I don't know if people, again, sorry, and one more thing. I've got so many one more things. Let's just get close again here. I've tried one more time, well, on revision 3, but as you can see, I just can't get the silk on this side. I can't get labels readable. They're slightly too big now, and you can't really read what they are. So I've tried one more time getting them a bit smaller, but I'm pretty sure I'm going to drop them for the final version of the board on the top. It's a shame, I know, but there's just no room for them. Like, I might be able to get a couple of labels on the silk around it, but I just can't get them all. I mean, clearly the back, they're labelled better. I was a bit annoyed about the... they put the customer ID on here because it wasn't panelized. So that kind of makes it a bit messy. You see that big long number? But I think the labels on the back are quite clear now. You can read them. They're better than what they were on the TinyPICO 1. These are a bit small. So I've made the labels bigger. But I'm still annoyed about the top. I think the best feature of the Tiny layout is the pin spacing, as it will nicely fit on breadboards. Yeah, it's a pretty good size. I don't have a breadboard nearby. Hang on. Breadboard. It's for all the OCD people out there, sorry, it's not an even spacing. So it does that whole 2 on one side, 3 on the other. I apologise. Right? It'd be nice if it was 2 and 2. Originally it was 3 and 3. Not that I can fit that in. Yeah, originally it was 3 and 3. Now it's 2 and 3. I don't like uneven boards, but what can you do? Make pick your phone. What's it? David Watts, man. People be people. Thank you, Peter. Sometimes I feel like my speed at learning is by jumping over things, skipping learning things. Sometimes. I tend to always go back and try to fill in the gaps later, but if I can get away with not marking it, then you can as well. Yeah, I can get away with not marking the top silk. I just like it when the silk is marked. I mean, this is the ideal, right? Is where you got space between the pins and other things, and you can fit them on the inside, like what Adafruit do. But I removed that ability by going narrower on the board. I just don't have the space for it. I mean, if you look at how close the 2104 is to the header pins, like, yeah, I'm already worried about being able to solder these things. Like, I'm worried about people wrecking the components on the side here when they try to solder header pins on. So, Peter, the way I figure out what to ignore is I look at does it have maths? Does it look complex? Is it more than a paragraph? Well, skip it. You could probably get the extra pin row by making it a bit longer. Slide Pico to the right and spread power supply a bit more to the left. Yeah, I don't particularly want to make it longer if I don't have to. I know I can, but I just don't want to. If I don't have to, like, at some point I need to lock in the size, because it's going to make a difference to doing shields or anything. Like, I've already got a problem now with where did I put it? With my idea of doing my colour OLED shield is the screen literally touches the header pins. You know what I mean? Like, that's tight. Like, I feel worried about making a shield that's got header pins that potentially are going to solder to the side of the screen. Yeah. I've done myself a disservice by making it smaller. But my plan was always to try to squeeze it smaller. So, you know. I mean, that looks, to me, it looks massive now. And that looks better, but yeah. Bigger breadboards are common. Yeah, bigger breadboards are more common, but I mean, this is, look at that. I mean, there's stacks. There's stacks of size. I'm really happy with that. I mean, you look at the size of the feather, you know. Are you within the spin spacing of the D1 mini boards? Am I within? Yeah, I'm way within. There's the D1 mini. Could they be used as shields? So I'd have to build an adapter board, and I reckon I could. The thing is, I'm not even, so it would have to sit offset to one side. But I could build an adapter board that could potentially let you do Wemos shields. I have only won the 6, just checked, can't even find them online. Yeah, I got, Rob sent me some awesome breadboards that are 6 on each side, I think. Are they 6? Yeah, really cool. Which is great for something this size, right? Because this only gives you 1 row on each side. Oops. And I often find 1 row on each side just isn't enough. Like, especially if I want to do, you know, if I'm doing using Spy with a couple of devices or a couple of things using I2C, I want to be able to use multiple pins. It's very annoying. Wow, I'm just piling up microcontrollers everywhere right now. So I could definitely potentially do an adapter board for a WeMOS that then allows you to plug WeMOS shields into it. Truth is, I don't have any WeMOS shields, so I'll have to get a bunch of shields and then build an adapter board. I want to do at least like a prototyping board. I don't even know if it's worth doing shields for this now. You know, I'm not sure what shields would be. Originally, my idea of doing shields was to be able to put LiPo charging on as a minimum. But I don't know what shields I could possibly use. Like, you know, what good really is a tiny little screen like this as a shield anyway? Like, you know, this is powerful. Like, I'd rather just plug a screen into it. You know, like a TFT or something bigger, maybe. Yeah, I mean, it's cute. Definitely cute. I can see that on Hackaday so easily. This board on Hackaday? Yeah. The Hackster people are being quite proactive about chasing me down, finding out more information about it. Fed up with chucking a nano in a smaller board, then hooking that up to a larger board to gain extra pins. It's, I think this is smaller than a nano now. Where's my nano? I'll grab a nano. I mean, it's the same width as a nano, I think. Yeah. It's the same width as a nano, but much shorter. That's pretty cool. Not that it matters what I'm comparing it to, right? So, haven't solved the battery flicker thing though. Where's all my... Here we go. Let's see, I'll keep that nano. I've got stacks of nanos, dude, don't you worry. I'm not going to run out of nanos. So my charge, obviously all my charge circuitry works, which is great. I forgot to mention. I've charged and it's cut off the battery multiple times, like 5-6 times in a row I did it. But what I have noticed is that, I won't get the battery out, that I've gotten even faster. You can't really tell on camera. Oh, you can see it flickering. I've got an even faster flashing orange LED now when there's no battery plugged in than what I had before. I'm not quite sure what that's about. It's using the same components, although I do have some additional circuitry on. I can show you over here. Got a desktop. I've got some additional circuitry. This is a slightly different layout because this is my revision 3. So this program, this prog resistor is what determines the speed of programming, but I've got it going through an NPN transistor now to be able to switch off. Well, it doesn't switch it off. It basically says if there's no USB plugged in now, because it's pulling the USB power, then it basically says I have no resistor here on prog, so it thinks it's not supposed to be charging it. It's like putting a 0 ohm resistor there. Faster flashing, less capacity on charger IC output. Yeah, I don't know, Christos. It went faster when I lowered the resistor, the prog resistor, which means it's faster charging. So the bigger the resistor I put on here, the slower the charge and the slower the flash. So I think you're backwards there. But anyway, when on battery, does CPU reset when you plug in USB? Does battery act like a UPS? It doesn't reset that I know. Hang on, when on battery does the CPU reset? I'm not sure how I'd determine that, because without having like a screen or something plugged in, come back to here, without like plugging like a screen into it to be able to see some output, the only way I can I can only see serial output if my USB's plugged in. So I don't really know, to be honest with you. I don't think it resets. Just don't know how I could try to put some... What can I put on there to try it? I could possibly stick the reset pin on my scope and see whether the reset gets changed. Do you want me to leave LED on? Which one? The blue one? Okay, let me just reprogram this. We'll try it. Just gonna go. Let me just grab some blink. Do I have blink anywhere? Be one moment. File open. Blink. I'm just gonna turn it on and leave it on. Hash define 13. See you, Colin. Thanks for joining. A rainbow LED scroller would show reason. Yeah, I'm not sure that you'll even see a blink, but we'll try it. Okay, set it high. Comment that out. Okay, I'm just programming it now. So we should see the LED just come on. See you, Michael. Take care. Thanks for joining. Wow, it's 9:15 already. Delay maybe a second on power on. We'll see. Okay, it's programming, connecting, programming. How bright is that little LED? That's an 0402 LED. So, now you want me to... let's put battery on. Okay, so we've got battery on, LED's on. So if I plug this in, you want to see if it flashes. Here we go. If I can plug it in. Nope, didn't see a flash. Did anyone see that? Anyone see a flash? Add a delay to the start section of the program, so if it reboots, you'll be able to spot the reboot. That's not a bad idea. Let's I'm going to put a 1 second delay before the LED turns on. Okay, so hang on, I'm just reprogramming it. I'm going to make it so there's a second delay before the LED comes on. So if it reboots, the LED should turn off, then come back on again. Okay, no reboot there. Oops, which I'm on screen. No reboot. Just keeps working. So yeah, no reboot. Watch me blow it up by just doing this. Okay, still on. And everything on. So yeah, that's pretty cool. Out of interest, just curious to see what my battery is reading right now. Oh, wow, might want to pull it out. Okay, it's a bit blurry, sorry. See if I can get it a bit more in focus. Ground and Battery 4.16. Yeah, it's almost charged. I've been charging and uncharging this all the time. So it takes a while. It's a 1200 milliamp hour battery, so it takes a while to charge. But maybe if we just let it sit there for a while, it will, charge light will turn off at some point. Lost one of my little things. Oh well. I assumed that the same behaviour of the battery was swapped over while powered. Yeah, it shouldn't matter. Actually no, if you unplug the battery and plug it in again, it sometimes doesn't start charging. I've seen this on all the boards I've got. So, right, so I've unplugged it. If I plug it in, sometimes it charges, sometimes it won't charge. God. Okay. Come on. Just let me turn it over. Yeah, see, it's not charging now. Plug that and plug that back in, it'll start charging. That is voltage level dependent. But I found a China single cell charger 313 5V that works that way. It works great as a UPS. Yeah, it probably sees it as full. I need to see if, let me see if I can find a deader battery. Hang on. If I unplug this one, I don't know if it sees it as full or if it just, I mean, so I had the same behaviour on my Feather and on my Wemos, my Lowland. I plug this battery in, hasn't been plugged in for a while. Right, so that's charging when I unplugged and plugged it in. See, you could be right. It could just be at that threshold, Chris, where it thinks, oh, it doesn't need to charge it. Looking for the link. So all in all, it's behaving really well. See, interestingly, the USB port also gets quite warm. So this is running, it's got the LED on, but I haven't turned any antennas off. So I wonder what this is actually pulling in terms of power. Let's find out, shall we? I'm just curious. I'm going to run it off 3 volts off the battery. 3.7 volts off the battery. Because why not? Turn it on. Right. So that's running, that's 64 milliamps right now, just to have the LED on. 64 milliamps. I wonder what it would be with the extra LED on. Let me just plug it into USB and change my voltage. I'm just running at 5 volts. Right, so now it's 73. Whoa, whoops. It came off. Try that again. Shouldn't have, I was holding the thumb thing on it. Whoops. Try it again. Here we go. So that's 72 milliamps. And that's because the antennas are on. If I was to do the same thing, let me just turn it off. Alright, plug it in and turn the antennas off as well. Just give me a second. Alright, we'll put some code in to do that. Oh! Something else I didn't show you all. Ah. Something else I forgot to show you. Something really cool. Oh god, I'm an idiot. Hang on. Let me just reprogram this first. Something unexpected, something very cool. I hope the thermals will get better with 4 layers. It's still a board size issue, right, Peter? Like, that's a tiny ground plane. Oh, hang on 1 second. Something cool that I added to this board that I mentioned in my last thing, but no one's asked what they are. But let me just do this first. So that was 72 milliamps. So it's compiling still. Okay, connecting, writing. Come on, LED, turn on. Okay, so I just want to, so now that so that was 72 milliamps. I'm now going to do the same thing again. So this is with the Bluetooth antenna turned off and the Wi-Fi antenna turned off. Oh, 73 milliamps. Did I not turn them off? That's weird. Why is it so high? Oh, 67. What did I miss? I must have missed something. That's okay. Anyway, I want to show you something cool. Turn it off, plug this in. So that code that I had before where it went to sleep and woke back up and went to sleep and woke back up, I'm just going to program that back on again. And I'm going to show you my output log on the screen. Okay. You can see it's programming down here. Bum, bum, bum. Maybe this might be a bit of a giveaway. You can see this. Font size, increase font size. Can everyone read that? God, why is this taking so long to compile? Okay, I'm going to turn that off. That's really annoying. It's so loud. Okay, there it goes. Connecting, writing. Dun, dun, dun. Okay, everyone watch the logs. Every 15 seconds. Wake up. Wake up, caused by timer. Charging, no. VBAT, 4. No, don't worry about VBAT right now. But look at this. If I plug this in. And now look at the log. Charging, yes. VBAT 3.76. Can everyone see that? So I'm not sure how many of you remembered from my last stream when I was going over what I was going to do with revision 2. There are 2 GPIOs on the Pico that are input only. So they're pretty useless to break out, and that is number 34 and 35, which is here, these 2. So what I did was I took 34 and 35 and I stuck some voltage dividers on them, which is what these little, you can't even see, but what the, yeah, it's too small. I'll show you later. It's what these resistors are. And one is going to VBAT, and one is going to stat. And so what I've done is got some code, and it's ugly code, and bear in mind that the VBAT, the battery charge check is total, it's very approximate, right? Very approximate. But what I'm doing is I have some code, so this is my battery voltage. right? The DAC is got to divide by 4096, and to detect if it's charging, I'm going through a loop. I'm doing it 10 times and grabbing the measured voltage because there's a flicker sometimes on the LED. So what I'm doing is I'm reading the state of the stat pin. When the stat pin is low, it's charging, and when the stat pin is high, it's not. But because it flickers sometimes, it changes state. And it's also based on 5 volts. So what I've done, well, it's not based on, it's not, but it's definitely, excuse me, higher than 3.3. When it's not charging, I've seen values up to 3.9 volts. So what I'm doing is I'm going through a voltage divider here of 180, which is reducing it back to the 3.3 volt range, and the same with the VBAT. I've got that going through a voltage divider of 2 100s. And so I'm determining if it's charging. If stat is low, then it's charging. If stat is high, then it's not charging. And it's working 100% reliably. The reason I'm doing the loop, though, as I said, is occasionally, if I read it, I'll get a false positive 1 out of every 7 or 8 times because of the flickering of that state pin. So by doing it 10 times, if the value is greater than 0, then I know that it's not charging. And if the value is 0, then I know it is charging. Does that make sense? Sure, I could also read. I'm out of pins. I'm out of I/O, Chris. I don't have another I/O I could plug it into. So I thought that was a little nice thing to have. So they're built in now. You'll be able to read 35 and 34 to detect whether it's charging and what a rough approximation to voltage is. It's not ideal, you know. But it gives you a good enough indication to know whether you're close to the high end or close to the low end. Yeah, I thought that was pretty cool. I forgot to mention that. So that's what these little 402 resistors are here, the 4 of them. What value are those resistors? So I've got determining the voltage, I've got 2 100k resistors as a voltage divider, and to determine the stat, I'm using 100 and an 82 to reduce my over 3.3 volts down to the 3.3 volt range for the I/O pin. What have I missed? Hello, Looney. What have you missed? Wow. I'll start again from scratch, everyone. Does everyone mind if I start again from scratch? No, I'm not going to do that. I'm using full gauge to determine remaining battery capacity, but the specific IC I'm using is damn near unobtainium. Yeah. I didn't want to stick another IC on here, so I just tapped into the stat and the VBAT using the voltage dividers to do it. It's inaccurate, but it's good enough. Like, you know, if it's charging, I know the battery's under, and if it's not charging, I know the battery's good, and that's pretty much all I really need to know. You know, reading the VBAT, I don't know how useful that is. Maybe to show a little gauge, maybe, but excuse me. Wow, I'll be better one day. Just as soon as I'm better, I'll get sick again. You watch. Remaining capacity is pretty good. Being able to know the remaining capacity. But knowing whether it's charging or not, I think is kind of cool. So that's why I implemented both. And I had both pins available. But, you know, it did add, 4 more passives onto the board. Little tiny passives. Maybe I could take them down to 0201. What do you think, everyone? If I ever get my microscope working, maybe. So if I ever get my microscope usable, I might do that. I don't know what that extra little bit of space will save me, though, so I'd like to get the Pico further away from the antenna if I could, but I don't. Whoops, you realise I wasn't even zoomed in. But I don't know how I'm going to be able to do that with these tracers without moving a whole bunch of them to the back and adding more wires. So the other thing I did with my revision 3 is I haven't gone down to the minimum wire size yet. I can still drop it further, which will give me a little bit more space. But I don't like working at the maximum tolerances that a board manufacturer can do. I'd rather be a couple of levels higher for safety. Just like I could also go down to a slightly thinner trace on a lot of the signal stuff, but I just don't want to. I'm on 6 right now. I can go down to 5, but actually I think I can even go further. I can go lower on 4 layers, down to 3.5 I think. Getting the IC further from the antenna wouldn't increase RF issues. A longer trace isn't necessarily a problem if it's the right impedance, right? It's about being the right impedance. But I can't calculate that, so I don't know. And we're talking about a millimeter, right? I don't think a millimeter is going to make, you know, much of a difference. Like what I need to solve on the RF is, you know, what is impedance? Oh, loony. Someone post that Bill Hurd video link again for Looney so he can watch it. So that's it, folks. That's my Rev2. You know Volts? I don't know. I've never met Volts. Is he nice? That's my Rev2. I'm looking forward to Rev 3, just to know if, you know, if anything improves. That'd be good. And my first 4-layer boards. So as I said, there'll be a sponsored video for the Rev 3. That was my deal with JLC PCB. I don't know when that's going to happen. I guess at some point after I get my boards. It might happen after I've built Rev 3. I don't know. We'll see. I'm really impatient to see if Rev 3 is going to work. And I'm a little bit worried about getting rid of the bias resistors on the little NPN, dual NPN IC. Because obviously the change in the board means that I can't easily put them back on again if the new IC doesn't work. And that'll be a shame if my auto reset fails to work. But we'll see. It's worth a change. Worth a gamble. So we just got here. What's up with your microscope? Well, how you doing, Andy Mouse? I'm still waiting for the eyepieces. It's been 10 days now since apparently they shipped. Yeah, I'll blame Chris if it doesn't work. I'm just waiting for those. So my microscope works like from HDMI output, but I can't use it sitting here like this yet with my eyes, so I'm still waiting for that. So this was put together with my magnifying glass, which was okay. It really was okay. It's not too bad. Can get closer again so you can get a good look. There we go. Yeah, I just made stuff a little bit too close. Print from some TPE. What? What did I miss? Oh, thanks, David. What am I printing? Print some from TPE. Pico Born. Eyepieces 3D. Oh, right. No, I don't want to. No. No. I've been printing enough stuff for this. Oh, look what I did! I've got to. Hey, Maxint. Is Maxint still here? I forgot to show you guys. I meant to show you guys first. Okay, I'm going to have to zoom the camera back out. Sorry. I designed and printed a divider for my component racks. They're on a slight angle, which is really frustrating, both sides. It's you can't really tell, but there's like a 1 mil angle either way. Really annoying. So I prototyped that yesterday, and I've got dividers now that I can put in my component racks. Because what I'm doing right now is, so I've got this one here which has got 2 different types of caps. is because they're just on individual strips, I've gone through and I've labelled each one what they are. 1.2, 1.2, 1.2, 1.5, 1.5, 1.5, in case I ever cut them smaller. So I've got just two components sitting like this in there, but what I can do in the future, if I put the divider in, is I can cut them up into smaller strips. So I like that. It's for the injection molding. Yeah, sure. It's just very hard to measure the angle of it. I've just been approximating. It's not quite. It's a little bit tight now. But tight's good. And it fits inside the rack really well. So I don't like it that it's black. I might print some clear ones. But it was my first test I did last night. And, oh, Peter. Is Peter still here? Oh, Peter is here. Yes. Peter, I want to show you something. Hang on, one moment. Okay, back. So, just to show that I don't always ignore everyone. Not always. I tried what you suggested. I haven't tried it yet, as in I've made them. I've done some with an angle. That's not in focus. Come on, focus. Thank you. I've done some with an angle to see whether it helps at all. And I've made sure that I've frosted every direction. So I have to pull these apart and try them in my Wi-Fi clock. I don't think it's going to make any difference, but we'll see. As long as it's not worse, then it's fine. So David, was it you or was it Peter? One of you two suggested this idea. Okay, maybe it was you, David. Whatever. Whoever it was, see, I do listen. It was David. Apologise. Okay, Peter, you can go back to sleep. That's fine. Sorry to bother you. You can doze off again now. I'm sure I'm putting a lot of people to sleep right now. Yeah, so it'll either work better or it'll work the same. I do listen. And I apologise if I ever get frustrated when I'm communicating back or whatever. Sometimes it's also just overwhelming, you know, like the amount of content that comes in the chat, trying to read it all and answer to everyone and stuff. Hang on, Sebastian, I was about to ask why you didn't use those tiny Wente boxes. Yeah, I don't like those boxes. I'm really happy with my component boxes. Like, I'm not looking for a different component box. I get that there's a lot of wasted space in some of them. I mean, you know, 430k. Hang on. 430k resistors, yeah? I mean, they're 0402. There's 100 of them here. But that's all it is in a box, right? I mean, that's like wasted space. I get that. That's why I'm looking at making the dividers. But I'm really happy with the solution. I don't want loose parts. I do not want a container with 100 loose resistors in it at 0402. That is just crazy. So I'm happy with my component racks. I know a lot of people on my videos have suggested alternate racks or alternate compartments and stuff. I'm not looking for that. I'm just looking for... So that my aim with my component stuff is to have them nearby, right? So when I'm working on a board, I've lost one. Oh, here it is. When I'm working on this with the magnifying glass or the scope, I want everything near me. I want all my parts out. But what I don't want is loose passives everywhere. Because, like, it's one thing to put all my bigger components, you know, I put them all on my tray. Like this, you would have seen in my videos. So I've got them all accessed if I can recognize them, but I don't want loose passives everywhere. So I want to make sure that when I'm looking down and I'm working, that everything I need is right next to me. Like, I want to grab all my trays from here, pull them out, pull one out. I don't have to be standing up and moving, sitting back down all the time. Does that make sense? So I'm just trying to work out the best solution for me. You can't really tell. This desk is really deep. Like, I'm half a meter away from the wall still, right? I can't... If I had my component racks on the wall, I couldn't get to them. I'd have to stand up, lean over, and especially if I've got a camera in front of me like this, if I'm trying to video what I'm doing, it's not ideal. So if I was setting up like a bench to assemble stuff, and I didn't have to worry about streaming or videoing, that's a different story, right? I could just put racks wherever I wanted to. But I've got stuff, like I need to keep this whole space clear for my microscope, for my magnifying glass, for my camera. So I'm trying to find a solution that allows me to have things close by and where I don't have to get up. Does that make sense? So it's a little bit unique. You know, like Azzy, was it Azzy or was it, no, it was Ev posted a comment that he put his racks, like the whole not attached stuff to the wall fear that I've got, that he put some wood and he attached them to the wood, and the wood is bolted just one tack to the wall. I can't do that because I can't get even close to my wall without standing up and moving. Hey, Azzy. So, yeah, like I know there are lots of solutions and ways I can do things. I'm looking for something that's quite unique to my needs right now. Like this whole having a camera in my face really gets in the way of setting up a really nice usable desk, if that makes sense. I need another articulator arm for my parts. I need lots of hands with all my... I need to be able to push a button, or I need a voice command. Give me 0402 100k resistors times 5, and suddenly they appear on a conveyor belt. That'd be good. To get the cheap vacuum pickup. It's way faster than using tweezers. Have a proper foot switch and vacuum release. I have a foot switch for my vacuum pump, and I have a vacuum pump, cheap one, like the fish tanky one, which I use to do all my NeoPixel assembly stuff on my boards. I can't do 0402 with it, or 0603. I've tried. The parts, they spin. They change orientation. Like it's, I don't know. And I'm pretty steady with the tweezers. I don't mind working with the tweezers. A lot of experiments to come up with the ideal. Okay, cool. I'm looking forward to seeing how you do it, like, and what you use though as well, David. I think the key for me is I'm using the wrong end. I've got like a bent end with those little suctiony things, but I can't seem to pick up small components with it. They change orientation. They flip. And also I can't see them. Like these 402s are smaller, excuse me, than the little suctiony thing. Need a component delivery robot. Yeah. Or a pick and play. I mean, I'd love to go pick and place. I just can't really. I can't justify a pick and place that can do 0402 properly right now. Simone will build you. Yeah, she'll build me a robot that'll grab my parts and throw them in my face. Don't dump them out. What am I dumping them out? What? I do keep them in the carrier strip, and I pick them up from the carrier strip, and by the time I go in to place them, they've spun. That's what I found with mine, but it's just as I said, it's a fish tank pump with a... I don't have the end on it. I've got a different end on it right now. Can't even... Let me see if I can get this out. I don't know if I can. Whoa. Okay. So I'm playing tangled cables right now. It's one of these fish tank pumps with one of these. This is not the end I normally use. This is massive. This works for the NeoPixels, but it's just one of these things. And I've got a foot pump attachment for this down there. But yeah, I just find that the issue isn't the suctioning and letting go. It's the parts just seem to rotate. I'll end up with components up my nose. Yeah. So I'm looking forward. I'm going to have a try of this today. And see if these improve at all. And I want to finish off the case. And I don't know if people saw on Twitter. Twitter and Instagram and stuff, but I've also finally started working on a case for my LED signs PCBs. So as you can see here, there's access for USB. And the button and the LDR. I don't know how I'm going to cover that over yet, or if I will at all. And this just snaps in. I don't know if I can snap it out though. That could be a problem. There we go. It's a tight fit. So it's just using little, you can see with the light, little pins and little side holders just to hold the acrylic in place, and a little gap down the bottom here for the extra bits of solder. And so that just snaps in place like that, nice and sturdy. And now I have to do the next sections above that. So I've been tinkering away with just building bits of cases and stuff. I've got hex holes at the bottom to hold the screws. So yeah, tinkering away at lots of different things. I'm not for sure how it works out in production. I have to do about 80 of those boards. Yeah, I'll be interested to see how that goes, David. Oh yeah, that big tip wasn't for the small parts. I've got a small tip. But I found that the small tip just with the metal doesn't hold the part properly. And if I stick one of those little tiny pad things on it, you know, the suction-y pad, it's very small. I don't know where it is. But it's still too big for the part. It's bigger than an 0402. Oh, hello, Brian. That's not a TinyPICO. No. That's a TinyPICO. Or that's a TinyPICO. Brian woke up. Isn't it really late for you? Everyone's late to the party. A few people late to the party. Pick and place uses suction. So it must be possible. Oh, it's definitely possible, but the heads on the pick and place machine are much smaller. Although not the... So again, the light pacer apparently can do 0402, and it can do 45-degree orientations. But I don't think it can do components this close. I'd be very surprised. Looking at the videos I've seen, I don't think it can place two components this close together. Or these two here. I did move these caps further away. If you look here, I had them... They were really close. There was one here really close to the IC. That makes kind of rework impossible. So, I mean, $3,000 is a lot of money to spend on a light pacer to see whether it can build this. And I'm just not prepared to do that right now. My local hackspace, well, it's not quite local, it's about an hour away. They are trying to get funding at the moment to get a light pacer. So if they do and they get one in the hackspace, I can always try. I can use theirs and see if I can assemble something. But I really don't think it's an option for me. I think I'd have to lay out my boards in a way that makes it pick and place friendly. Yeah, there's not a lot of suction on that aqua pump thing. It's really not good. I think if I had more suction, it would hold the part still. But I feel like right now the suction's not enough and the part tends to move a little bit. So it makes it very hard to place accurately oriented stuff. What? Whose children are being children? Brian used insomnia. Super effective. What happened? What did I miss? What? Yes, Brian's very fashionably late, but that's okay. That's okay. How many pixels have you got, Brian? A lot? Anyway, it's been almost 3 hours. I thought this was going to go for an hour. I thought I was going to run out of stuff to talk about ages ago. But I think it's time to call it. Been an awesome stream, everyone. Thank you. Thank you all for your suggestions and help again. I look forward to sharing the results with the revision 3 once I get them. As I said, it's probably not going to be till next week. Maybe Sunday. I might get a DHL delivery again. But most likely it's going to be next week. And I'm hoping my parts will also come around the same time. They're coming in 2 different orders, unfortunately. JLC PCB wouldn't let me attach my parts, my LCSC parts to my order because they were giving me freebies. So I had to pay for shipping on my LCSC stuff. I was wondering if Brian had child-induced wake-up time. Ah, right, yes. He might have. Anyway, thank you all. Rob, have fun playing with your microscope. I'm jealous because you can actually use yours. Thank you all for stopping by. Oh, this is what I started with the vacuum tool. Okay, let me just... The problem is I forget and I close the chat. And then I miss the... I have to go back and find it on YouTube later. Cool. Thank you all for joining. It's been great. And once again, I apologise if I got frustrated with anyone. It wasn't getting frustrated. It was me getting frustrated with myself. Biggest child in the house is my house is me. Thank you all. I really appreciate it. And we'll continue the journey later. Look out for my video on Friday. It's a bit of a doozy. It was a tough video to make and do, and you'll see why. Let's go pick up tools. Okay, Dave, I'll chat with you about that off stream. Thank you for that link. I'll have a look. Thumbs up, everybody. Yay! Ring the bell, Andy. Yeah, you got to click the bell to be notified. No, but sometimes YouTube just doesn't pop it out. Doesn't pop the notifications out. Very cool seeing the birth of Pico soda be antennas. Sketcher 2 in the comments. Thanks, Peter. You're not a... What's a... I don't know what's a shalacer? I don't know what that is, but anyway. You're totally fine, mate. You're way smarter than I am, and I appreciate all of your help. Suggestions and guidance, I really do. I honestly do. It just gets really overwhelming, people pulling different directions. And I don't know the right decisions or the wrong decisions to make. That's me. Anyway, thank you all. I'm going to stop saying thank you. I'm going to actually shut the stream down now. But have a good sleep. Those of you who are going to go to sleep, and have a great day for those having a day. And I'll catch you all next time.